So section 6.4, we're talking about multiplying polynomials. And it's very similar to foiling that you're used to when you just have a binomial times a binomial. But now we're expanding that where it could be a trinomial times a trinomial. It could be a binomial times a binomial times a binomial. So it's just a little more advanced than what we're used to with quadratics and foiling those. So the book actually gives us two methods. One method is similar to foiling, and as an example, maybe I'll do both methods. How's that? 4x minus 7 times x cubed minus 8x squared plus 6x minus 11. Okay, so I have a trinomial times another polynomial that's got 4 terms. Okay, so we're going to do this foiling, which is really not foiling. It's just distributing each term to each of the other terms and then combining our like terms. And then we're going to do it using what the book describes as the box method. That actually is a really nice method to keep those of you who kind of struggle with your work and keeping it organized and not really able to lead your own work after you do stuff. The box method is a really nice method to keep your work organized. Okay, so let's do the distributive method here first. So I'm going to take the x squared to all 4 terms first. So x squared times x cubed. X to the 5th. Yep, we add the exponents. X squared times negative x squared to the 4th. X squared times 6x is 6x cubed. And x squared times negative 11 is negative 11x squared. Now, we could just go on with the 4x and do the same thing and just carry on the same line. One thing that I do is I will kind of group. So if I'm going to do the 4x now to all the terms, right? So 4x times negative 8x squared. It's going to be an x cubed, right? So I'm going to put it underneath this one. Okay? 4x times negative x squared is negative 32x cubed. 4x, I don't know why I skipped x cubed. 4x times x cubed is 4x to the 4th, right? 4x times 6x is 24x squared. And then 4x times negative 11 is negative 44x. Okay. And now I've got the negative 7. I don't know. It's going to go to all 4 terms. So negative 7 times x cubed is negative 7x cubed. Negative 7 times negative 8x squared is 56x squared. And negative 7 times 6 is negative 42x. Negative 7 times negative 11 is plus 77. So, looking at these, I don't have any other x to the 5ths. Did I miss something?
How did you get x to the 5th? Oh, 3, 4. How did you get x to the 5th?
Because
X squared times x cubed.
Oh, okay. Okay.
So I have x to the 5th. Negative 8 plus 4 is negative 4, x to the 4th. 6 minus 32 minus 7. Well, 6 minus 32 is what? Negative 24. Minus 7 is negative 31. Negative 11 plus 24, that's 13. Plus 56 is 69. And negative 44 minus 42 is negative 86. That's it. Did I do it right? Negative 33. I did something wrong here. 6 minus 32 is 26, right? Plus 7 is 33. So I did my math wrong there. So this is the answer at the bottom in the blue. Okay, now let's do the box method with the same problem. So what I'm going to do is write my terms. I have x squared plus 4x minus 7 down the left. And then what I'm going to do across the top is the other polynomial, x cubed minus 8x squared plus 6x minus 11. Okay, and now I'm just going to, for each one of these rows, I have 3 terms, so I have 3 rows. I have 4 terms, so I have 4 columns. Didn't do those very even, but you understand the idea. And now what I'm going to do is just multiply the respective, like for this first box, it's going to be x cubed times x squared, which is x to the 5th. This box is going to be negative 8 x to the 4th. This box is going to be 6x cubed, and this box will be negative 11x squared. I'm just taking the number on top times the term in the row. And then I'm going to do the same thing with the second row. 4x times x cubed is 4x to the 4th. 4x times negative 8x squared, negative 32x cubed. 4x times 6x, 24x squared, and then minus 44x. And then the last one, negative 7x cubed plus 56x squared minus 42x, and then plus 77. So now I'm going to go through and combine anything that has the same exponent. So I look along all of my boxes, and there's nothing else with an x to the 5th. So that one's done. Now let's do the x to the 4th. I have negative 8 plus 4. And is that the only 2 x to the 4th? Yes. So that's negative 4 x to the 4th. Let's do the cubes. I have 6x cubed minus 32x cubed. That's negative 26x cubed minus 7. It's negative 33x cubed. Now the x squareds. I have 56 plus 24, which is 80, minus 11, 69. And then the x's, I have negative 86, and then plus 77. Same thing I got before. It just kind of keeps your numbers, your terms organized.
Oh, and like all of the like terms are going to go diagonally.
Mm-hmm.
That's nice.
All the like terms go diagonally, so that's a good observation too. Yeah, so you can use either method, whatever you're most comfortable with. I kind of like the box method because it keeps your work organized. But if you don't write neatly in the box, it doesn't matter. You're still not going to be able to read your own writing. But you are able to kind of go through and systematically combine your like terms like that. These aren't hard. They just take time. I mean, it's no different than foiling before, but now it's just more multiplication.
It just looks more because it's in a box.
Right. Okay. So something else, you know, I guess if you guys know this already, but if I just have one term on the outside, okay, all I need to do is just distribute that term in. There's no special, it's nothing different than what we've been doing. Okay, so you just are going to take negative 2x cubed times x to the 5th to give you negative 2x to the 8th, because you're adding your exponents, and so on.
Can we do number 1 again?
Sure. Let me do one more example. Well, if you get a problem like, let me find one. This one. Something like this. Okay, think of it as this times this, whatever that is, times this.
Yeah.
Okay, so just do these two first and then this one. But I would tell you, you're always trying to minimize your work if you can. And this problem, when I look at it, the things that are in the last two parentheses look to me like the same thing but a plus and minus. So I know that started as a difference of two squares, right? There's no middle term. So when I see that, because I know what that pattern is, I can look at it and I know this is just 9x squared minus 16. No middle term, because the plus and minus. So this is 9x squared plus 12x minus 12x goes to 0, and then minus 16. So this just, when I FOIL it, gives me this. So if you would recognize that first, you're going to save yourself work, because now all I have to do is multiply this times that. If I had gone this way, I would have had more work. So look for some of those patterns. Save yourself some time if you can. You'll get the same answer if you do it the other way. It's just going to take longer. Okay. And then one of the last examples they did here is anytime you see this, is this equal to 4x squared minus 49?
No.
No. What is it equal to?
2x minus 7 plus 2x plus 7.
No. It's equal to 2x minus 7 times 2x minus 7, not plus 7. Yep. But you should be able, at this point in Algebra 2, tell me what that is without having to FOIL. You square the first term. You square the last term. And what is the middle term?
0.
This times this times 2.
So 14 times 2 is 28.
Mm-hmm. And the sign is whatever this sign is. Okay? If you can do that pattern, you're going to save yourself time also. FOILing will give you the same answer. But recognize things that you know patterns for. Okay, what was number 1?
It says it is parenthesis 2x to the power of 5, y to the power of 3, parenthesis, negative 4, xy to the power of 5.
The whole thing to the power of 5?
No, like y to the power of 5, sorry.
Okay. Okay, so this one, how many terms are there in the first parenthesis? How many terms are there in the second? 1. So I'm not going to be distributing to multiple things. All I need to do is I take 2 times negative 4. X to the 5th times x is x to the 6th. Y cubed times y to the 5th. Y to the 8th. That is it. So be careful here. Don't think you're going to take 2 to the negative 4 and 2 to the x and 2 to the y to the 5th. You only do that if it's separated by a plus or minus. If it's all multiplied, then it's all multiplied. Okay? Any other questions? All right. Mm-hmm.